Hello and welcome back to a new video here on the Lötwig Fusel channel. In this video series C++ libraries, we're gonna in each video take a look at one certain C++ library to understand how it works and how you can use it for your project. Now in today's video we're gonna take a look at JSON, or better to say JSON for modern C++, how they like to call it. Now JSON is a really popular C++ JSON library. It is completely header only. And it's also featuring a single header version, which is also why it is that powerful and mostly used. It is really used quite often. If you are taking a look at the stars at the Git repository, 34,000 stars. This is a big number, and yeah, in general, it's really popular here. Now, it is also popular because it kind of like tries to empathize the C++ library, a standard library, and kind of like adapt its style into this library here. And this is also what we want to do. We want to also, yeah, kind of like use the standard library style, and this is why we're going to use JSON, and why I'm going to promote JSON in my video series. And it's the only JSON library that I'm going to cover, at least for a long time. Now, you can download a single include here by going to single include and Lohmann, and you're going to find json.hpp. However, what you can also do is you can also acquire Lohmann through a package manager. We're going to use my template repository moxpp that you can find at github.com/moxibye/moxpp. This is a template repository that provides some scaffolding around Conan 2 and Premic 5 and provides a cross-platform, or better to say Windows and Linux environment for building C++ code, and it has Conan on board, so you can start easily. What you would do is you would use this template and create a new repository. However, since I'm going to have multiple subdirectories for each of the libraries that we're going to cover, I'm actually going to take the template and put it in manually. Now, this is not too much work at all. It's just, imagine a way of actually copying like a few files to a directory, and we are done. Now, to show how popular or how good my template is, we're going to see in real time how I'm going to customize that one. I'm going to change that name to JSON. I'm going to need to do this at 2 points for the project and the solution. Now we have completely migrated that one to JSON, and now there's only one thing to do. We just need to reference the library. We have it on Conan here in the Conan Center and Lohmann_JSON. And well, I'm basically just going to provide the package ID here, and the only thing that I need to do is mox init. This is how the system is built. Of course, I need to be in the subdirectory, and what it then is going to do, it's going to install everything, and it's ready. Now the solution is called JSON, so I'm going to enter in the name JSON, press enter, and now we're going to get a full-featured environment for building with JSON, and that's amazing. This is why I love my template, and my template repository is going to change in the future. I have big plans on what I want to do with it, but I don't want to spoil too much because I can't guarantee that they are going to be implemented. All right, so now let's get started. I actually write a bit of code for JSON. Now, first of all, let me do a few standard includes. I want to have some IO stream, and since JSON are files on disk, I actually want to include fstream as well. Now, let's actually include JSON itself. Where can we find JSON? Well, we're going to find it in Lohmann/JSON.hpp, and there we go, and JSON ready to use. Now, of course, if we want to read a JSON file from disk, we need a way to actually read something. So moxpp is set it up so that the app directory is the working directory, so we can create a file called settings.json in here. If you have a custom setup, you need to make sure that you put that file in the correct location for your system. And now I basically just want to start and provide a bit of customizations. Now I want to write an application that you can control how many threads you want to have. I'm going to set this in this case to 8, and then this application is also going to provide a web server, and this web server is going to have a configuration of a host. The host is going to be in this case local host, and then it's also going to provide a port setting, which I'm going to set to 88 since I have some kind of web service that I want to run. Now that's everything that you need to do for JSON. You can see that it's really readable and nice to structure, and now we only need to read this into C++. Now how do we read that in? Well, basically the problem with JSON, or not the problem, but the design of JSON is that it's not aware of files. So there's no way like do something like JSON from file. There's nothing that works for that. You cannot read something from file. And this is actually by design. And JSON works similar to the standard library with streams, and the input file can be a stream. So really what you want to do is you want to actually now work with a stream instead of actually working with the raw file or the file path. So what you want to do is you want to open up a if stream, so an input file stream, and call this one like maybe for example JSON file stream, and then you're just going to provide the path settings.json. And that's the only thing you need to do. This can now be fed to JSON. What is the function in JSON? The function is called parse, because it parses a stream to a JSON data. So if we provide the JSON file stream, we can parse that. Now in JSON, of course, supports multiple versions of parse. You can, of course, provide a string and do something like inline text, which I would then recommend like doing a raw string, because of all the quotation marks that JSON provides, like dummy lel, for example. This would also work. You can also parse a inline string. I think there's also a way to do like a char pointer the size, I think, or maybe not, but there are multiple ways of that, right? So yeah, there's an iterator version of it. There's a version with iterators and with streams and with strings. So really you have a hell of a lot of options how you can parse something. You just need to make sure that it comes in the format that JSON can actually understand. All right, so now that we have parsed the JSON file, where is it stored? Well, nothing. You can actually see, and JSON is going to return a JSON value. This is the class and JSON, and this is going to be the JSON data. Now, of course, this is not always going to work. This is only going to work if the JSON data is valid. If I run this, of course, it will work because I have produced valid JSON. However, I just want to raise a bit of the awareness. If I do provide invalid JSON, and JSON is going to throw you an exception. So if I add some garbage like that, I'm going to have an exception in parse error with JSON throw and stuff that's going to happen. Now, this is important to note, and JSON will throw, so if you want to do it properly, not like I'm doing it here, I'm not doing it properly today, then you want to, of course, also check for exceptions. If something happens, throw the exception. In general, if you're working with libraries like XML libraries, JSON libraries, like libraries that parse some data that is coming from the disk or from the user, you should never assume that it is good, and you should always have some way to detect if something is wrong. You can either go for it. We're going to take a look at this one later, how we can actually try and make JSON as less exception throwable as it is doing. There's also a way to kind of like configure it and make this set this kind of like default that it's not going to throw, and then it's kind of like working with booleans or with dummy values. And yeah, I don't know. There's a hell of a lot of ways you kind of like can go around it. However, I just recommend wrapping the kind of like initial code that handles the parsing and exception handler. And then from there on, continue on with like return false or something like that. Because it's going to give you the information on what is wrong, of course, in the exception text. Now, let me actually fix that issue because we don't want to work with that. Now, since we have the JSON data in, how can we actually work with it? Well, since the JSON data is working natively with streams, you can also, of course, push the JSON data to an SDDC out, because this is an out stream, and basically print it to the console. This works. Of course, it's now trying to recompile, but I want to restart. But this is, of course, going to work. Invalid or corrupted file. Yeah, because I do a quick clean solution here, and then I'm going to restart this. Because I basically had the try to recompile and reload, and then it produced some corrupted data. Visual Studio can't handle that. Instead of recompiling it, it just complains. However, there you go. We have it. We're going to have the server in here with the host, the port, and the thread count. So everything works. You can actually see that this is formatted differently, and it has a different order of the object, so we are not like plainly outputting the data that we have in the file. We are really like outputting a representation in memory that JSON loaded. Now, JSON supports something called pretty printing. Pretty printing basically means printing out the values in a pretty format. How do we make this pretty? We use the property std_zw. ZW is kind of like setting the width. In this case, I'm setting the width of the tab size, and in this case I'm going to say the tab size is 4, and if I provide a tab size of 4, if it is not 0, if it's kind of like bigger than 0, and JSON will pretty print this one, and in this case with 4 spaces as a tab, and you can see now it's looking a bit more like what we had in the initial JSON file there. So of course, if I can print this to the console, I can of course also print this to a file. So if I have an auth stream, an output stream, and we'll call this one json.out./out.json, I can, of course, also, instead of printing to the string stream, I can, of course, also just print to the output file stream, and it should work. If I do this, I should now have a duplicated file called out.json with the same data than the settings.json, but differently ordered since it has been between parsed by enloma.json. There you can see thread count on the top. If I go to out.json, it's the other way around, but we kind of like have the same format. Of course, we can also work without pretty printing on the file stream. This is especially useful if you are kind of like shipping your JSON file and you want to reduce the footprint of your application. Then I would recommend that you're basically having a build step in your deployment, which is basically taking all the JSON files, pumping this quickly maybe through enloma JSON, and then outputting it in a non-pretty way. Then it's going to look like that, and it's going to be a hell of a lot more compact. I don't know how it is, but if I could reveal that, you can see this is 60 bytes, while that one is 104 bytes. So it's like not the double of it, but nearly the double of the size, just because it is like pretty. And at the end, if it is at the customer and the customer shall not change the file, it doesn't really matter if it is pretty or not. Alright, so now that we have explored how we can read and write JSON data, either to the console or to files, or from files from the console or whatever, we now want to actually go into and actually analyze what is inside of this JSON container and not just print it. Now, how can we access the data of the JSON container? Well, it is actually quite straightforward. If I want to have the thread count, which is like at the top level of the JSON, I can just say JSON data, use the array operator, and provide my thread count property. Do a std handle. If I do that, it's not a big deal. It shall give me the number of threads that are kind of like used or configured in the JSON file. There you go. Thread count is 8. In my Visual Studio codes here, thread count 8. And of course, I can also change this and maybe make this to 12 threads. And if I rerun my application, we're going to get 12 because it gets loaded from the JSON file. Now, let me quickly do this for all of the other ways as well. Yeah, maybe let's start with one so that's simple. So the server host. But well, how do we now actually get this server host? Now, if we are taking a look at the raw JSON data, you can actually see that the host is under a different JSON object called server. And if you want to kind of like access that, you need to first access the server, and then you can actually access the host. If I do that, server host, and I run the application, I wait a few secs, and then we again gonna get our property localhost. However, you're gonna see that it's looking a bit different than our 12. You can see that the 12 was printed correctly, however, localhost was not printed correctly. Localhost was printed with quotation marks, however, we did not enter the quotation marks in the properties. Well, this actually has something to do on how we are printing it. Actually, as you can see now, we are directly printing raw JSON values. If you are accessing the JSON data with the array operator, you're gonna get kind of like a JSON node or a JSON sub-object. Now, if you're printing a JSON sub-object, it's going to print its value as is. And in case of an integer, the value as is just the integer. Yeah, but if you have a string, the value as is kind of like the string in quotation marks, because we basically need to indicate that it is a string. If you really want to get below the raw values, you can actually do this by calling the get function. The get function is a templated function that tries to convert that the data that's stored inside of the JSON field, it's trying to convert that to the type that you specify. And if I say I want to have it as an std string, and I run the application, we should now have this correctly converted to a string, and now we also, because of that, are rid of our quotation marks. Now, this also works by the thread count. I can actually do that one, and I can actually provide, for example, an integer here, or an unsigned integer. However, this is really not mattering. Numbers are converted by enloma JSON. However, you can do that. You can just say, all right, I want to convert this to an unsigned integer. And it's not really going to change the output. However, this is now checked. Previously, if I would have changed the thread count to a string, it would went through. If I now change the thread count to a string, it will no longer went through because it's now trying to be parsed. And if the parsing fails, we're going to get an exception because type must be number but is. And in this case, this would be kind of like string. Previously, if we would not have the get function, if I would remove this quickly and rerun the application, you're going to actually notice that this is no longer throwing, but in the other way actually going to output us some value, and in this case, the 12 in quotation marks. However, this is not what we want to do, because we want to have this definitely as an unsigned integer, and we are okay with it throwing. Now let me quickly also add this for the server port. The server port is actually not a string, it is another unsigned integer. And of course, we also want to adopt this here, server port. And if I do it like that, we have everything that we got in our JSON printed to the console with proper type conversion, so the proper type get. And there we go, we have our values. Now, what I also want to show you is I also want to show you a way to properly check these values without getting exceptions. Actually, Enloman JSON implements the whole concept of iterators continue throughout. So instead of kind of like going through the way of accessing the data via operators, we actually fully access the data with iterators. So actually what you can do is you can try to find a member of the JSON object, for example, the member thread count, and then you can kind of like parse it. So for example, this is an iterator, auto iterator tc for thread count, and then I can say like if it tc not equals JSON data.end. So if it is not the end iterator, so it exists, then I can kind of like, try a few things with it. For example, TC now has a key, which is thread count, and TC has a value, and this value can actually be parsed in multiple ways. You can, for example, check if it is a number unsigned, and if it is a number unsigned, you can say something like, so if it is unsigned, you can say thread count is valid, exclamation mark. And if I now run my application with the current thread count, we're gonna think that we're gonna get the output thread count is valid, and we of course get it because the thread count is 12, which is a positive number, so we get that the thread count is actually valid. Now what we can do is we can try to mangle the thread count to 12.5 to a floating point value, and if I would make that to some invalid floating point value, let's see what happens. And as soon as this starts, you're going to notice a few things. You're first going to notice that it has actually converted this to 12, so the value seems legit. However, it did not checked. We didn't get the message that the thread count is valid. Well, this basically happened because this is also a number. This is a number, and a number can be converted in an integer, or a number can be converted to another JSON number. This number is actually a float, and if we want to have all the data of it, we can get it as a float. However, a float can be converted to an integer, so this is why JSON or Enloman JSON has converted this to an integer for us. However, it does not check out that it is valid because that one is explicitly checking it and therefore not validating the current request. Now you can do even more things with Enloman JSON, and these iterators you can actually iterate over a whole JSON object. So what you could do is you could do for auto it equals JSON data begin, it not equal JSON data.end, and then plus it. And what you can do is something like SCDC out, iterator.key is, and then you kind of like want to provide the value. If you provide the value like that, it's gonna be quite easy, and it's gonna print it out. If this is gonna run, you're gonna see a few things. So of course you can see that, oh, I did forget a new line, this is bad. A new line is important. Handle, so let's provide an handle. Because if I don't have a new line, we can't really read what's going on. And now you can see, for example, that the server is host localhost port 8080, and the thread count is 12.5, which is still the bad value. Let's make this actually good again, so that we have a valid thread count. And let's now rerun this. And now we again get that the thread count is valid and we got the right values. So actually, as you can see, we have many ways of actually accessing JSON data. And it's the same when we actually want to write JSON data. So if we want to create a new JSON data, we also have many options to use. Now, let's get started by basically creating ourselves a new JSON object. I'm going to call this one JSON new for new JSON data. And we're also going to later on print this one to out because I want to have my new object into JSON out. Now, how do we populate one of these empty Enloman JSON objects? Well, it is actually very straightforward. We just provide the key, like A, and say A is 5. Or let's say 7, because I mistyped. What you can then also go is say something like B is 1.99. You can say that like C is false, and D is hello world. can do this. There's no problem. If I let this application run, we should have a file with all of these properties specified and not pretty printed. Now I want to have pretty printing because I want to initialize this. Set W4. Let's rerun this quickly so that we get a pretty output of that. It's actually taking quite a long time to compile because JSON's header only and header only libraries are always a pain for compiling. And there you go, A, B, C, D, 7, 1.99, false, and hello world has been all correctly emitted to our JSON file. Again, this is not order dependent. The order could be completely different. The order in JSON doesn't matter. Now, what I can do even further with that is I can actually even go and allocate arrays. So if I want to have an array, a JSON array, I can do this by providing a simple initializer list, and then I'm going to write 5, 6, hello, false, true, 1.88. I can basically provide this an initializer list, and if I run this, all of these values will be correctly emitted to the JSON object because it is basically supporting the standard library in all its extents. And now you can see that we have this JSON array with 5, 6, hello, false, true. Now the same actually even works for objects. You can do this with objects as well. So you can provide a JSON new and you can provide an object. Now objects work a bit different. They also work with initializer lists. However, the members of the object needs to be provided in another initializer list wrapped. So like A is 2 and B is hello. And you can actually even nest them more together. You could provide like an array of it. Now if you want to provide an array, it's actually quite simple. Yeah, just like 1, 2, 3, 4, and 5. So you have nested an array inside of here. Now what you can also do, of course, is you can nest an object in an object. So like O for another object. And then inside of here, you basically then gonna provide the object attributes. Now for objects, we again need initializer lists. So 1 is false and 2 is true. Now this is getting ugly quite soon, so you need to be 100% sure that you know what you're doing with these, and you shouldn't overdo nesting objects in Loma JSON like that, because you easily make a mistake there. And if you make that mistake, it's gonna hard to spot. At least you should try to make this a bit more visualized. You can see object A is 2, the array inside of the object has the values, B has the text, and O has an object nested in an object with 1 and 2. So this all works. This works with initializer lists to the end. You can overdo it quite well with Endloma and JSON, but it has the possibility to do this. If you are creating a empty array, that's also possible. So E array, if you want to have it empty, you do not provide that because this is basically null. This is creating an empty JSON object, and an empty JSON object is by default null, so this doesn't work. However, you can tell in Loma JSON to create yourself an empty array by using the array function, which is going to return you an empty array. Same works with objects, eobj, so empty object. You can do this with Endloman JSON object. And if I run this like that, I should have an empty object and an empty array stored inside of my JSON data. Let's wait a few seconds, and you're going to see that the E array is an empty array, and the E object is an object. Now, if you want to access them, it's of course not a problem. You can go to JSON new and the E array, and you can basically call the pushback function, and you can push back everything that you want, like 5 and XD. Yeah, maybe XD. We could also do this differently. Same goes for the object. If you have a new JSON object, you can just treat it how an object would work. A is 1 and B is 10. So they all work. If you create an empty one, you can of course manipulate them however you like and however type it has, and you want to kind of like modify it. And if I take a look at these now, yeah, you can see that the E object has been populated, the E array has been populated, because we basically modified them after we have created them in an empty state. All right, so this concludes the tutorial or the kind of like introduction to Enloman JSON. I hope it was useful and provides a good starting point for your journey in, yeah, basically integrating JSON to your projects. Hope you enjoyed. Make sure to like and subscribe, and have a nice day. Bye.